This is experiment 16, equations and calculations and graph for part 2. So the graph that you did in part 2 should have been on the x-axis, voltage in volts, on the y-axis, charge in coulombs. And then we're going to try to get what our capacitance in part 2 is. So for that, you're going to say capacitance is equal to permittivity of free space times area divided by distance. If you don't understand that, refer back to the previous video on part 1, which equals, just plug in some numbers. These are exactly the same as what they were in part 1, and now distance is something that is constant throughout this entire experiment, which should be 0.03 meters, 3 centimeters, which equals a number in farads. Then you have to check if you were successful in this part of the experiment. So to do that, you're going to do your slope, which is going to actually be farads. So here's what you're looking at. Slope is rise over run, and the rise was coulombs, and the run was volts, and a coulomb per volt is a farad. So then we can say that we have slope minus capacitance 2, which is farads minus farads. That theoretically should be the same thing as our capacitance 1. However, that's not necessarily going to be accurate in the lab, so you get a margin of plus or minus 25% to see if you were accurate. And then, so you're just going to write out an inequality. So you have capacitance 1 minus 25% should theoretically be less than or equal to the slope of part 2 minus capacitance 2, which should be less than or equal to the capacitance 1 plus 25% of capacitance 1. If that's a valid inequality that you wrote out, then this was successful. If not, then your part was not successful.